Nice. All right. So, all right, we're doing lesson 4.2, and this is the title says angle relationships in triangles. So this is everything about angles that you need to know, basically. Now, we're going to still learn a lot more with triangles. This is just kind of an intro thing. A lot of it was pretty simple. The review here, it says how to classify triangles and definitions. Guys, please understand, if I ask you to classify by side length, do not classify by angle measure, or vice versa. Or if I ask for both, give me both. But you need to make sure that you know those well. Those are very easy questions to ask on a quiz, especially if you use a complete sentence, right? So make sure we have those. Now, the next thing, if you see drawn here, is a definition. It's called an auxiliary line. And it's a line that you use when you need to really figure out a proof. Now, you need to remember something about the very beginning of geometry. If you guys remember the first day I told you were just sitting a bunch of points, and that everything's just a bunch of points, and there's really lines coursing through you right now that you can't see. When you draw in an auxiliary line, aren't you drawing one that wasn't seen, but that's actually there? Yeah. So we're going to do the same type of idea. So the very first theorem is one that you guys already know. All right, it's called the Triangle Sum Theorem. So triangle, angle, sum theorem. So it means I'm adding up the what? And we've been talking about this, and we've used this already. What do the angles of a triangle add up to? 180 degrees. Now here's the question, why? I know teachers have been telling you this for a long time. I've expected you to know this already for a long time, but why is that going to work? Now I'm going to do a very informal proof, okay? This is going to miss a few things, but it gets the big points. Are you guys with me on that? So this is not a formal proof, but I'm going to give you a proof, and it's going to use that red auxiliary line. So if I was doing this informally, the first thing I would tell you to do is draw auxiliary line L parallel to segment AC. Now, why can I do this? Do you guys remember the parallel postulate? The parallel postulate says that if I have a point not on a line, how many lines go through that point that are parallel to your first line? Only what? Only one. So I strategically chose to draw my auxiliary line so it was parallel to one side of my triangle at a vertex. So I was really strategic where I put it. Then I'm going to use just some things that I already know. So first of all, and this is why this is informal proof. I'm like putting a couple gaps and reasons together. But guys, what does angle 4, angle 2, and angle 5 all add up to? 180, right? So the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is equal to 180. Now, this is really two reasons in a row. Do you guys agree with me? Sum of the parts equal the whole, right? So sum of the parts equal the whole. And what's the whole? 180. It's the straight angle measure, right? Remember, this is when we use straight angles to help us out. Otherwise, I don't like straight angles at all. And that's really, and the measure of a straight angle, which is the line. I'm basically combining those in one step. So again, this is why it can't be formal. I'm leaving gaps in my proof. There's just two different ones together. Sum of the parts equal whole and the measure into 2, 4, 2, and 5 all add up to 180. I'm going from here to here. All right, and the thing is I need 2 there because that's 2 is also one of my angles on my triangle, right? Now, we drew, so I had parallel lines. Does anyone see some alternate interior angles right now? Yeah, we see them, right? Angle 1 and angle what? 4. So angle 1 and angle 4 are congruent. All right, so I go here, I got angle 1 is congruent to angle 4. I have another pair of alternate interior angles I should also have. Which ones? 3 and 5. Yep, 5 and 3, 3 and 5, yep. So I also know that angle 3 is congruent to angle 5. And really, I put them in the same step again because aren't they for the same reason? If parallel lines, then alternate interior angles are what? Yes?
Could you also have that angle 1 plus angle 2 this one? If lines are parallel, the same side interior angle.
Yeah, but you have to have all 3 angles. You'll see, we're almost there. Oh, that is a nice stink bug up there. Okay, guys, we have to ignore the bug. I can't reach it. All right, alternate interior angles are congruent, right? Now, guys, look at this. Next step, just because I can't do math without it right now, is I'm just going to sit there and say they're equal in measure.
Why they call them stink bugs?
Because they stink when you crush them, and the smell does not go away. All right, so this is definition of congruent angles, right? Now, guys, now that I have equal signs, can I do some substitution into number 2? Can I replace 4 with which one? 4 gets replaced by what angle, guys? 1. And 5 gets replaced with which one? 3. So look where I'm at. Really, I'm basically at the therefore statement. I know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. Because what I did is I substituted in 1 and 3 for 4 and 5. And this works every single time. Notice I didn't need an actual measure of an angle to do this. But the reason why the angles of a triangle add up to 180 is proven because of parallel lines. Isn't that crazy? Kind of cool. Now, you should be able to apply that no matter what. So go to the next page. And these are some easy ones to start off. We'll be doing some practice with these because you have to be really good at doing this, my friends. You have to be able to look at a triangle or triangles and solve for the missing angles very quickly. Now, on the very first one, it's pretty easy. I only gave you a simple triangle ABC, and I'm looking for the measure of angle 1. So we could literally say, oh, look, the measure of angle 1 plus 35 plus 65 is equal to 180, using the Triangle Angle Sum Theorem. Now, some of you are like, do I really want to do all that work? But can't we just say the measure of angle 1 is equal to 80 degrees? Now, could you also just say, okay, now here's the thing. Some of you are like, well, I can just do it in my head. Have I ever taken the fact that you can just do it in your head ever? No, you have to show your work. So could you also say the measure of angle 1 equals 180 minus 35 minus 65? Could I do it that way? So that's options for you to do. Like, you don't have to show it exactly the way that I do, but you can use some good math at least to give me an idea before you put your answer down what you did. Make sense? More than one way, and that's okay as long as you're mathematically correct. Now, at B, we had a little debate on this at first. Hopefully we'll get everyone on the same page. How many triangles do you see for letter B there? 3. A lot of people see the obvious 2, but I also have the big one, right, that includes both. So don't forget, a lot of people do. It's not going to let me do this real quick. All right. A lot of people forget that you can use the large triangle as well. So if you're looking for the measures of angles, you have 3 different triangles you can approach. And there's probably 3 different ways you can even start it. But what would be the angle that most of you would have tried for first? A, B, or C? C. Most people, believe it or not, those of you who say A actually made yourself go through more work. Those of you who said C, I think you're more logical this time. Okay. I know, but why do it if you don't have to? So, yeah, so when you have here, if I'm looking at C, I know I have the other 2 angles are 44 and 53. So I can literally go, all right, 180 minus 53 plus 44, which is 97, right? Which is going to give us 83 degrees. Or 93 degrees. Someone double check me. 53 plus 44, 97. Yeah, should be 83 degrees. Notice, what did I do with that angle after I found it? I wrote down my answer, but what else did I do? I marked up my diagram. Because the moment I marked my diagram, what letter can I find really fast? Yeah, I can solve for B really quickly because we still can use linear pairs to our advantage, right? So don't forget that. So 180. Guys, it's not going to hurt you. It's a bug, okay? All right. You go and get chances of concussion on the soccer field and you're scared of a bug. Stop. Okay, don't go there. Okay, so we have 97 degrees. Again, if I write that angle in, now can I solve for A really quick? Now, there is 2 different ways of solving for A. I was just being a little bit mean earlier. The thing is, if you can get A 2 different ways, I don't care which way you do, as long as you're right again. But one nice thing you've got, if you get 180 and you subtract, make sure you subtract both of these. Guys, here's one thing you need to remember, and I'm putting parentheses there, but if I put parentheses there, doesn't that mean I have to subtract both of those because I'd have to distribute the negative sign? Correct? So don't forget to do that, or, you know, if you want to, you can say, I got to do inside the parentheses first, and so that would be 125, which gives you how many degrees, guys? 55? Now, there is another way to solve for A. Could I use the big yellow triangle right there? Because 28 plus 53 does not give us, isn't that 81? So if that's 81, I can use 81 plus 44 plus A. So those of you who said you're going to get A first, is that okay? But make sure you're using what you have. Show me work so I can at least follow your thought process. All right, the next problem says the angle measures of a triangle are in the ratio of 3 to 4 to 3. A ratio. That means fractions, right? Fractions that have been reduced, right? Fractions that have been reduced. So the thing is, that's called an extended ratio because you're comparing more than two numbers. You're comparing how many? 3. And so when you work with this, this is how easy it is to do. Guys, look. Put a variable after each one. Now, one of the angles is what? 3x. The other angle is 4x. You can even see it in a diagram like this. 3x, 4x, and 3x. And what do we know about the angles of a triangle? Yeah, they add up to 180. So you could literally just add the three of them together to do so. And I get 10x is equal to 180. X is going to be 18. Am I done? No, I have to find the angle measures, so I have to give all of them. So I got here 3 times 18, which is what? 54 degrees. I know another one's 54 degrees, so does that take care of 2 of my angles? Notice, did I list it once or twice? I had to do it twice. And then I got our other one is 4 times 18. It should be 72 degrees. Those are the measures of your 3 angles. Yeah, you could do it that way. This is an easy way to check if you're right, though, right? Now, here's the thing. You will see these again. You will see applying ratios. You'll have to know how to work with these. Make sure you know this stuff. Some people really love these and they go, oh, this is great. And some people hate solving for angles. It's harder for them. It's a visual thing. But understand, I don't have to give you pretty little looking diagrams for you to do well. Yes, Jacob.
Will this work for like any ratio problem?
A lot of times it matters what you're doing with it exactly. Yeah. All right, now the next thing is a new definition, and it's the word corollaries, if I can spell it right now. Corollaries are just theorems. Did everyone hear what I just said? They're just what? They're theorems closely related to another theorem. So the idea that the angles of a triangle add up to 180 degrees really can influence a lot of different theorems. And these, I think, are common sense, and you can see, like, oh yeah, these make a lot of sense because of what they're working with. So here's our first corollary, and no, there's not a name, you just have to know it. It says the following: the acute angles of a right triangle are complementary. What does complementary mean again? How much? So it's 2 angles whose measures have a sum of 90. Guys, think about this for a moment. If the 3 angles of a triangle add up to 180, and I take away 90 from it, how much do you have left for the other 2 to add together to be? 90. So no matter what, they're complementary. Think about this now. I can use smaller numbers. I don't have to. Now, if you forgot this theorem, could you probably solve for stuff anyway? Yes, but is it a time saver? Also, if you're ever doing a proof and you need to talk about complementary angles, wouldn't this be a really easy one to use? So, one that helps. Here's one that we've already used. We talked about it yesterday. I asked you guys. The measures of each angle of an equiangular triangle is what? Yeah, it's 60 degrees. Because we just know it's 180 divided by what? No matter what, there's 60 degrees. Again, someone's like, oh, that's a theorem? But think about it. You couldn't know that unless you knew the measure of the angles to start with, right? So pretty simple, easy ones you can do. Now here's some stuff that you'd be expected to do. So make sure you're looking at this as you go. It says the acute angles of a right triangle ABC are congruent. Find their measures. So those of you who are visual, doesn't that make sense to do that? How would I find the measure of the 2 angles? Someone said 90 or 180? Which one is it? 90. Yeah. Basically, though, I'm going to show you the algebraic way so no one will ever argue with you. If they're the same, can I give them the same variable? They're both the acute angles, so I know that they're complementary, right? They add together to be 90. Yep. It's exactly what you guys told me. But don't you have to write them down twice because there's two angles? So make sure you give me both answers. Now, at the other problems right here in example 3, it says the measure of one of the acute angles in a right triangle is given. Find the measure of the other acute angle. Yes, Jason.
Well, when people you like 45 equals A equals C. If you like draw the thing and then say A have B is the right angle, and A is C, you said 45 equals A.
No, but you're trying to show me that. We know that they're equal, so that's why I have the congruency marks there. I just didn't do it with a variable. And then you want to show that they're the same. This is actually a way more formal than what we did. So yeah, just make sure that you have the two that add up to 90. You're going to be good because they have to be the same measure. So I think, Jason, you're on the same page as me. On this next one, it says measure of one acute angle in a right triangle is given. Find the measure of the other one. Guys, think about how easy this is. The acute angles are what? Complementary, so don't I just have to subtract it? Now, this is where it's always interesting to see what people do. Because this first one, everyone thinks, oh, that's easy, just subtract it from 90, right? Wouldn't I do the same thing for the next problem? Because I told you, this is the measure. 90 minus z is a measure of an acute angle of a right triangle. How would I solve for its complement? Wouldn't I do the process the exact same way? So wouldn't I just go 90 minus the angle? It just means you're going to have an answer with a variable in it. That's all. Right? So I distributed my -1 through my parentheses. Oh, look, what happened to my 90s? BZ. Now, guys, go back to when we talked about complementary angles. If one angle is z, wasn't its complement 90 minus z? So it's not contradicting anything that we've learned so far. It's just that you're going to have a variable for an answer. Guess what? Variables can be answers. It's okay. All right, next one that we're working on. The triangle exterior angle theorem. A few things. Angle 4 is the exterior angle. How do I make an exterior angle? You just take one of the sides and you keep it ongoing. And notice you get a linear pair being formed between 3 and 4 there. Now, 1, 2, and 3 are called the interior angles of a triangle. Go figure, and they're on the inside. But 1 and 2 have special names. These are called remote interior angles. They're the ones that don't touch 4. So it's the other 2 angles that are not a linear pair with your exterior angle. And remote means far away, right? That's why we have remote control, so you don't have to go up and change the channel like I used to have to do as a kid. I was my father's remote. You know what I'm saying? He'd go, Valerie, go change the channel. That's what I would do for a living. All right. But so think about far away. Now here's the theorem, and this is cool. We actually could use this on one of our previous problems. It says the following: the triangle exterior angle theorem. The measure of each exterior angle, and by the way, that'd only be 1 at each one, of a triangle equals the sum of their measures of its 2 remote interior angles. All right. Now let's think about this for a moment. Why would this have to be the case? So again, this is going to be very informal proof. Are you guys with me? All right. Do you guys agree with me that this is true? Measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180. Is that true? Okay. So you guys agree with me? That's the triangle angle sum theorem. Basically our very first theorem today. The triangle angle sum theorem. Would you also agree with me that angle 3 plus the measure of angle 3, wow, my notation got really bad fast, plus the measure of angle 4 is equal to 180? Linear pair theorem? You guys with me so far? All right, so we got linear pair theorem. Again, I'm missing some steps in the middle, right? But we're all probably, you see where I'm getting it. If they're both equal to 180, can I substitute them equal to each other? For my next step, can I go the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 equals the measure of angle 3 plus the measure of angle 4? And that's just going to be substitution property. What would I like to get rid of? 3. Can I? Yep. Yeah, it's subtraction. So this one is really, it's all algebra. So I know the measure of angle 1 plus the measure of angle 2 equals the measure of angle 4. And that's just from subtraction. Does that make sense? So guys, finish writing that down, and then you hold your paper there, and I'm going to scroll back real quick, and I'm going to show you how we can actually have done one of our problems earlier. And this is one of those theorems, if you know, your life is way easier. If you don't know it, you made yourself really miserable in quizzes or tests. Hint, hint, make sure you know it. This theorem, yeah. If you know it, it makes your life a lot easier. Guys, I want you to look at this angle right here. Look at angle B. We said the angle measure was 97, right? What's 53 plus 44? These would have been the remote. B would have been the exterior angle. So the two remotes still added up to it. Isn't that kind of cool? So it's just another way of doing it. So notice that problem can be done like 3 different ways now. Woo, great. But you can do that. How about C? Is C the exterior angle, and then A and 28 are my 2 remote interior angles for that one? Mm-hmm. So you have a lot of unique things you can do with this. So let's look at these. They're pretty easy. Wow. If you know the exterior angle, please use it quickly to solve for your remote interior. But if you forgot, is there anything wrong with going like this and using the triangle angle sum theorem for triangles? Could you do that and solve for the measure of angle 2 very quickly? Yes. But if you recognize that 113 is your exterior angle, and these are your remote interior, can't I just use that instead? Measure of angle 2 plus 70 is equal to 113. What's my measure of angle 2, guys? 43 degrees. I didn't have to do a linear pair thing at all. I know a lot of people seem to struggle on these problems. It's amazing, Drew, how people don't study these for quizzes. Just saying, they just don't. And it's amazing how they don't know how to do these problems on quizzes. Right, Corbin? It's amazing how they don't do that. But think about this next one. I'm looking for the measure of angle PRS. So I want to know this angle is measured right here. A lot of people would do, and that I've had in the past, sit there and say, I got to use a linear pair so I can solve for x. Does anyone really want to subtract 9x plus 2 from 180 right now? What if you didn't distribute negative signs correctly and everything? Wouldn't that stink? So why not just use the rule that you have? Isn't this my exterior angle? Aren't these two my remote? If they are, can I just use my triangle exterior angle theorem? Yeah, it's really easy. Your exterior angle is equal to the sum of your 2 remote. And it's not a bad math to do. Now, I've done one to do this where you actually have to use a little bit of maybe factoring to solve. You know, things like that, not a big deal. So we get 4x is equal to 20. X would equal 5. Am I done? No, we got to plug it in. So we get 9 times 5 plus 2, my friends, which is 47 degrees. Was that really that hard? No. Okay, last but not least, I think common sense theorem that you have. And I think I still have time with you guys, right? I have you into 118. Oh, good. We'll be able to finish. All right. Next one's called the third angles theorem. So guess what angles we're going to be talking about? The third pair of angles. We're already going to be given 2 other pairs. So here's what it says, and you guys are going to think this is so common sense, which I think you're going to love because it's common sense. It's a huge time saver is what it does, okay? Because if you didn't have this theorem, you'd have to show it algebraically every single time. I'd rather use this theorem. So it says here, third angles theorem. If 2 angles of one triangle are congruent to 2 angles of another triangle. So if 2 angles of one triangle are congruent to 2 angles of another triangle, then the third angles are congruent. Now, we could do a whole bunch of math to show this, but we're going to run a little bit short in time, so can I just use numbers instead? I don't normally like using numbers, but I think this is a great way of describing it. So if I did something like this, let's just say this was 80 degrees. This angle is 80 degrees. So L and R are the same measurement. They're both 80. Let's let M be 40 degrees. But if M is 40 degrees, what does S have to be? 40 degrees. Okay, guys, what's 80 plus 40? 120. What's left for the third angle? So don't both of those have to be 60 degrees? So isn't it naturally, if they have the same measure, they're congruent to each other? And we're going to use that a lot to prove congruency. So we need those on a regular basis. That's a time saver, right? And the nice thing is you don't have to sit there, because if you do not have this theorem, you'd actually have to algebraically show how they're equal to each other first and then change up the fact they're congruent. I don't know about you, but I don't feel like doing algebra at this moment, right? So make sure you have those. But let's go there. It's really easy then. An example 5. Find the measure of angle E and the measure of angle G. Now, right now, first glance at this diagram, I'm like, I can't find that. First glance. But I do know I have a pair of congruent angles here. So what should I start looking for? For my second pair. Do I have a second pair?
Yes.
Where are they, guys?
Vertical.
You notice vertical angles still don't go away. Notice today linear pairs haven't gone away. They don't. Parallel lines, they don't go away. We still use them. So I now have 2 pairs of congruent angles, so I automatically know that our third pair, and I don't think I changed my color like 1 or 2. Yeah, my third pair are going to be congruent to each other. So then I can just set them equal. So I get 6x minus 4 is equal to 5x plus 4. So I get x is equal to 8. And now the cool thing is, do I have to plug it into both? Yeah, so let's do it to 1. I'm going to do it into G, so it's 5 times 8 plus 4. Did you guys get 44 degrees? Yep, 44 degrees. Meant to be as simple as that, what that seems. Yes, Peter? Yes, they would be. And then E and G, wouldn't those be alternate interior angles? Mm-hmm. Yep. If you saw it that way, you'd still get the problem right, correct? All right, next one, guys. Look at this one. I'm looking for the measure of angle T and V, but again, what's already marked on both of my diagrams? 2 pairs, so automatically, what do you know about your third? Yep, they're going to be congruent to each other, so we know those are going to be the same. So I get 10n minus 2 is equal to 9n plus 9. I get n is equal to 11. What do I need to do? Plug it in. That's right. So I get 10 times 11 minus 2, and I get 108 degrees for both of my angles. And make sure you tell it for both of them, my friends. Does it make sense today? All right, I should be around lunch tomorrow or lunch Thursday if you have questions. Remember, the quiz is still scheduled for Friday. Yes, ma'am.
These 2 angles have converged. Did you also prove that those 2 are parallel? Is that congruent to theorem, or?
No, because you don't need it. Because you can just use it. The fact they're alternate interior angles are current, so you have parallel lines. So you'll be good.